Good morning, and I must thank Professor Kao, Amita, and all the members of the organizing committee to have me here. After that wonderful and scintillating talk, it's very intimidating now to speak anything else. And this is more at a base level. That was at the technology at its best, or the technology which is being invented. So I will be, for the last about 10 years, I have been trying to introduce accelerator technology as a curriculum. And basically it arose because we were running, at IIT Bombay, we were running a very successful engineering physics program. And then the electrical engineering withdrew from it. And the students began asking, where is the E of the engineering physics? And basically it became more of a physics program. And that was the genesis of this thing. And so the outline, I would talk about the introduction, then genesis. One proposal I presented to the institute and to the Department of Atomic Energy, first to the Dr. Banerjee, who was then chairman AEC, and Dr. Kakotkar was our chairman board of governors, and both appreciated, but somehow then I'll give an example of how this could run and why this is needed. The curriculum also exists. This didn't succeed, but one should not give up trying. So I have been trying something else, somewhere else, and so I give a brief outline of where do we go from here. And all of you know this, but just to, it's the basic science of beams and particles, and it investigates and characterization, their production, manipulation, and their interactions with fields, plasmas, or matter. And it is believed that accelerator science will lead the way to future accelerators for every branch of science and for broad spectrum of applications to meet national needs. What was being discussed in the morning was, where this thing, but for common man, we would need it. And then, so this is how I pose the problem that shouldn't we then teach our kids accelerator science? And we often work at, frontier of technology, and this was also one of the electives that was proposed, the basis of the talk just preceding mine. And there is also in a global action for green environment, there is a lot of misconceptions about it, and we have to produce accelerators in the at mass scale, because we have to replace inefficient, environmentally harmful thermal processes with energy efficient green electron beam or X-ray processes. This is what was being talked, is a future technology, but such technology exists. How to make it cheaper so that it's, for purification of water, or for various other treatment of effluents from chemical factories. What do we need? So, education about safety records and environmental benefits of large-scale green applications would help to overcome these misperceptions and stimulate interest in industrial use of accelerators and nuclear. So this is how I had presented to Dr. Banerjee, and the mass education is only possible at an educational institute. You can create a center, but that's it's limited to very few people. And this was a report which was published, I think, 6-7 years back, and in Physics Today. And basically, there is a need for accelerator physics, and the title was that there's a dearth of accelerator physicists. So it's like robbing Peter to pay Paul. You take the manpower from one center and whoever is in need. So this is, I have lifted directly from that Physics Today article, and the remarkable discoveries over more than 50 years of particle physics were made possible because of progress and innovation in accelerator science and technology. However, it goes on to say that today accelerators are also critical to other programs in the Office of Science, National scientific enterprise, and they can significantly impact the economy, health, and security. And then it says the future of accelerator-based science and applications will be limited unless new ideas and new accelerator directions are developed. Likewise, the demand for trained accelerator professionals far exceed what can be provided by today's limited educational opportunities. And then US PSC or US Particle Accelerator Committee says that the sub-panel finds that there is an urgent need to strengthen accelerator science, technology and education in US. It talks of US in order to address long-term needs of particle physics, other sciences and the nation. And the idea was to fill this. IITs have been known as good educational institutes. We are known for our students, so we could have introduced this in our curriculum also. In Indian context, this is my personal view. It might not be this thing, but honestly, I think we are lagging behind considerably. At CERN, when I hear sitting in the control room, they say 1 TeV and going up, 1.5 TeV going up, and that is proton machine at 6.5 right now, or 13 TeV center of mass energy. They say 6.5 TeV and stable. And here we don't even have a 1 GeV accelerator, a proton accelerator. And this is primarily because, of course, IUSC is there, but development of accelerators has been limited to DAE organizations. And the accelerators, honestly, that's my perception, and have not that we have designed or taken copy from somewhere, they have not worked that well. So it introduces a sort of negative atmosphere in the lab, and so it's not a very sought after discipline from at least I know from VRC training school. And then the people who go there, the seniors are a little frustrated because they have not been able to get success, so they pass on this to the juniors and the cycle continues. So with this idea, I thought that if we can create an accelerator laboratory which is a happening place in an educational institute, and instead of building it from scratch, buy an accelerator and create a research facility around it so that it is working from day one, research makes it a happening place. So then the idea was to find something which was unique, which was not there in India. So this is what I told that time was to promote accelerator related research and interdisciplinary area in a technological institute, and develop human resources in accelerator technology. And the idea was to make a more meaningful contribution to these future accelerators, which were the electron ion collider is coming up, CLIC is there, and Japan, they have already a CDR, I think, comprehensive design report for the ILC. And then, as I said, you need mass production to have as much as mass production of tabletop accelerators at a later stage. So, and so that it's happening and just doesn't have some research activity associated which was not there in India, or not still there in India at this time. And now I have added BHU because that is the future, but IIT Bombay, IIT BHU also gives bachelor's and master's degree in electrical engineering, computer science and engineering, engineering physics, mechanical engineering and chemical engineering. My this thing was focused on engineering physics, but often the electrical engineers, the mechanical engineers work on a problem which might not be directly to accelerator physics, but can be applied. So if it's in such an institute, then when you when you talk to each other, then this could help. And the idea was to pick students in these areas and train them at master's and graduate level and in accelerator physics and technology by presenting to them the challenges in the field. And one of the topics, because Professor Kailash Rastogi was there, he only, one of the electives that we had proposed was this laser plasma acceleration. And the idea is that I don't find any student from our institute going to that field. They go to fields which we know and or which we teach. So if we have such, subjects, then the students would also be introduced to those subjects, and then they can go for graduate level or master's level abroad and learn, and some of them are now coming back. So this would have helped. So well, these are the programs. I don't want to go over it, but at every level we thought we could introduce accelerator physics in this thing. At in a dual degree program, IIT Bombay runs, IIT BHU runs, to have accelerator physics as a specialization. And I have a doctoral program specifically for that. And I had also talked at various places about this thing, and the curriculum was evolved after, giving talks and talking with accelerator physicists at CERN, at Paul Scherrer Institute, KEK, J-Park, and also at Osaka University. And the idea was that we buy a small machine and then upgrade it, and the students do projects which are related to this at one of these centers, so they learn and also contribute to the machine. Well, this is, I don't want to, but I just wanted to give you an idea that we had framed the syllabus, the whole curriculum for this course and everything. And this was the facility that we were asking, and we wanted to have 50 MeV, we wanted to buy a 50 MeV electron machine and have normal Linux. And then the idea was to, and on one station we had this electrons going through, on one we had, through inverse Compton scattering and shine laser from the other direction, and the third one, NPD from BRC had agreed to take it up when we hit electrons on a uranium carbide target, produce fission, and then separate it out for a radioactive ion beam. So this was this thing. This is what I had worked out, which was not there in the country, and this would have, of course, right now we don't have, but this would have provided energy between from pulsed inverse Compton scattered X-ray about 25 to 40 keV and about 10 to 6 photons per second. So it would have helped. We have a very good biological sciences, chemical engineering, material science. It would have helped there. We could have had Bremsstrahlung photons up to 25 MV, and the head NPD at that time had agreed that if we get this facility, they will develop a radioactive ion beam. Well, these are some of these things which I don't want to, this thing. It would have improved our research output of not only IIT Bombay, but we could have made it India, a wide range of sub-nanometer resolution probes to meet the needs of the emerging nanoscience and nanotechnology field. It could have offered high energy probes which are essential both for research as well as characterization in the field of basic material science, material engineering, chemistry, biological and biomedical sciences. And these macromolecules, they play an important role, and we could have done this also. Nuclei far from stability, various other things, and this was this was not so far not available anywhere in the country. It could have this enabled time-dependent studies of reaction and processes under relevant conditions and time frames. And this is how we envisaged. This was not a something that the nation couldn't have supported over next 5 years, and the budget that we were asking was about 100 crores. And the only thing was that the idea was to have a consultant, established accelerator physicist, one of the best in the country is something like a person who is retired as from CERN as director, LHC, to have him as a consultant who could guide us if we were going wrong somewhere when we designed. And then the idea was that 50 MeV we buy, and another we accelerate it to 200 MeV, and then Paul Scherrer Institute, who have undulators for 200 MeV electron, we could have gone for free electron laser. Well, the project did not go through, but all is never lost. Samir presented exactly the same proposal except for just for the producing radioisotopes. From DOE, it got 80 crores for building a 70 MeV electron accelerator. IUSC is building an RF gun, and probably with the help of KEK in a similar manner, and they have gotten a grant from DST. VCC is now building a radioactive ion beam with its own internal resources, which was also mentioned as one of the objectives of the center. We had also requested the Japanese to come. They were very helpful. I had given a talk in KEK, and Professor Suzuki, who was then the chairman, Director General of KEK, we had signed a MOU with IIT Bombay, and they were, since we don't, I mean, if I teach accelerator physics because I don't work in it, it will never be the same as if I teach particle physics. So I had requested them to come and give specialized lectures, and they were coming for last 5 years. This year I'm on sabbatical, so they have not come because they had asked money for it, and they give specialized course at IIT Bombay. Nowadays it's very difficult to, they were supposed to give for this course, and since they had asked money from the government, they have to come. So it is a little embarrassing for me and to find also the audience, but this has happened, and at least some people have gotten educated in this. So as I said, all is not lost. Build contacts with the Japanese, and from these contacts over this thing, I know that Japan wants to build the International Linear Collider very badly at their place. They submitted the comprehensive design report to their government, and the government in turn asked them 2 questions. That where is the I of the ILC, meaning international this thing, and where is the manpower to run the project? Europe has seen the power that LHC has given them, everyone converges there. So, and they don't want to let that power go. Plus they said that, you know, they want to increase if they can build magnets which can take higher magnetic field, basically they're increasing the energy to 20 TeV, center of mass energy, or 28 TeV would not be difficult. The only problem is bending the proton, which will move. The rigidity of the proton goes up higher, so you need higher magnetic field. And then they have this click, so I think they refused to endorse the program. They went to United States, and the United States wants them to endorse their neutrino program, and I think Japanese are far ahead, so they don't want to do it. And add worry to their woes, China most probably will go ahead with a 58 GeV E plus E minus collider. So it's in this since I knew this, it's sort of a scientific diplomacy. So I wrote to Professor Atsuto Suzuki, who I know well, and he's well respected in Japan also, that why doesn't it's very difficult to, converse with the Indian government, at least I have found this, to do this. If people don't reply, but so I asked him that, if you can fund this and set up a center, then, and at BHU, it would be very nice. And I just wrote, and he said, it's a very good idea. So, and after that, not only that, in April 2016, he visited BHU and saw whether it can be done. And it generated a lot of buzz in Banaras, which is a small town. The temperature was also very high, but he did take the trouble to visit it. So then before that I had done some groundwork. I met Professor Bhartendu Singh of the physics department, impressed upon him that why if he starts such a program, it will be first in India, and this can reach benefit. And with him then I met the head of the Department of Physics, the Director of Sciences and Vice Chancellor also, and somehow they appreciated that this could be done. So BHU in principle, I also met the IIT BHU director, or I tried to meet him, but he did not show much interest. So BHU now has agreed in principle to formulate a course in accelerator physics and technology. And the Japanese are, laying great stress on it. When it was signing of the MOU with IIT Bombay, it was signed by mail. But on January 30th, 2017, the present Director General of KEK along with his team visited BHU and the MOU was signed. And the idea is that they teach us how to build these cavities for the ILC, and also so we bake them and test them and then supply it to Japan if India joins this. So right now I would say the ball is in our court. Japan needs our help. They want to go ahead with ILC. If we can rise to the occasion, they will teach us this art which we don't know. And at the, very rarely that scientific and political this thing, but even at the political level, there is great comradeship, and we have the manpower, they have the technology, and there is willingness. So I think it could work. Oops. These are, of course, not what was being talked in this thing, but this was feature technology. These are high gradient accelerating cavities of 31.5 million volt per meter. If we move fast, they will teach us how to make and test, because it is in their interest. It helps them, if India joins, it helps them to answer both the questions that their government asks. Their project becomes international. We are producing manpower, so they could answer. India would have pride of taking part in making cavities for ILC instead of making jacks for the magnets. And we could also make our own tabletop accelerators. And once the technology exists, we could develop expertise to make proton cavities with similar or little less accelerating gradient. But one of the avowed programs of Department of Atomic Energy is ADSS, accelerator-driven subcritical system, and we don't even have a 200 MeV proton machine. So this would be a step in the right direction. Thank you.
Any questions?
There are some nuclear physicists there.
And so on.
There are some, we'll have to, they have to go to DST and ask for money. There are people whom had contacted Indians working abroad to come back and help us and offer them a position so that they can take up a job and do this. Right now there are only experimental high energy physicists. Japan is, right now, they went to the government. I think both Professor Suzuki and Professor Yamauchi, they went to the government. The government have probably told them that KEK has enough money, you can support this center. They are willing to. I mean, the very fact that the Director General and his team came just to sign the MOU means that they are willing.
So, Raghava, just a few comments. So, first of all, the situation I want to assure you is not quite as pessimistic as you seem it is. Specifically with regard to the penultimate transparency you showed, we actually now make superconducting cavities in India. We have a collaboration with Fermilab. who are also making proton linac, very similar to the two projects we have in India, proposed projects in India for ADS and spallation neutron source. So we have made superconducting cavities, and I think Dr. Roy can say a little bit more because much of that work has been done at IUAC. We've made spoke resonators at low beta for proton accelerators. We've made high beta super elliptic cavities at both beta 0.6 and beta 0.9. We have built RFQs for our domestic program, not for Fermilab. We have built other aspects of accelerator technology, such as the RF amplifiers, etc., which we will actually be providing to Fermilab. I think in that sense, the amount that we can learn that we need to learn has moved rapidly in the last, I would say, 4 to 5 years, and we've learned a lot of things that we did not know 5 years ago. And as far as the quality of the stuff we make is concerned, again, these cavities have been tested to gradients of above 30 megavolt per meter and Qs of above 110 to the 10. They are competitive with all other cavities that have been made for Fermilab by both American industry as well as European industry. So from that point of view, I think we are pretty good. I also have a brief comment on the manpower development. This point I take your point strongly that this is a very important step that needs to be taken up. The more people, the more universities that get into the business of teaching accelerator physics and accelerator technology, in fact, as you've quite rightly said, the better it would be. You may know that Bombay University has recently started a course on accelerator physics, which some of us helped structure the syllabus for. And as you may also know, it's at the Center for Advanced or Excellence in Basic Sciences in Bombay University campus, which is funded by DAE. We have a core course on accelerator physics that goes on. And I think this idea of propagating courses like this to train manpower is very important. But I would urge that you think in terms of using this manpower for the Indian programs first.
You know, these are all, I agree with you. And this is the question that was raised in the department also. You cannot, you cannot, force people to do it. Produce as many. First they will go abroad, then they will come back. And or produce in numbers. So because, if you say that you have to work for the Indian programs, then the program will lose its competitiveness. As far as, Bombay University and CBS, my main point was that there are people in electrical engineering, there are people in mechanical engineering, there are people in chemical engineering who are doing stuff which could be used for accelerator research. For your point, I'm sorry if, this was wrong information, but I asked some people in CAT, and what they said was that what you say is correct, that they have produced 30 million volts per meter, but when you actually put them in this thing, the gradient is much lower. But I know you may be more correct. This is around what has been achieved is 15 or 16 rather than. Okay, so I'm. Pardon? Is the world limit, I thought. And okay. Yeah, because Delhi University, the premises on which the Delhi University course was started, to send people, you must have a research lab within. Yeah. Yeah. I was talking of a 30 MeV electron accelerator. Yeah, once you learn. But so far we have only been duplicating it and duplicating it without understanding. Well, the machine is still to come. I mean, we can make a proton machine, but where is the 1 GeV proton accelerator? From whatever I know, I mean, basically this is the.
About the know-how of building the accelerators, not the users of the accelerators. But at the same time, you are telling like you buy accelerator at the university level, set up some laboratory, use it for some other purpose. So I think these two are different aspects. Users of accelerators are, I mean, different, and so. Uh,
Also to catch some time. And, you know,
no, my own, please, yeah.
no, I was not talking of 1 GeV Linac. You have an injector like, Linac 4 of LHC, and then you inject it into a circular collider, but it takes a lot of time. Yeah, let's not, I don't want to be, yeah.
Any other questions? Can we have these discussions during tea time, please? Okay.
Just to answer,
Let me finish my point. My point was only that any course at the educational institute
yes.
will be successful only when it has a job perspective. So in that sense, if accelerator science and technology course has to progress, there should be enough opportunity either at the national laboratories or unless until these technologies are taken up by the industry and there are enough jobs are created.
India will have to create
so by just have, yeah.
So that is the point.
This is the 5 years back USPA. They have said there is dearth of accelerator technologies. As for your point of buying accelerator, the idea was initially the lab will work. So we buy a 50 MeV accelerator, it works. And then we increase the energy to 200 MeV and then borrow the undulators or take the technology from Paul Scherrer Institute. So the construction part was to increase the energy to 200 MeV. So the students had jobs to do.
Yeah, that's what I mean. I mean, they should have some basics to do at the university.
The point is the students who get trained in the academic institutions, you will be the benefiting thing because you have the job prospects. You will get good students, good people. So there is I think these two programs would be benefited from each other, complementary. So we can continue the discussions during